friends, welcome to sidschemistry and welcome to the show Crack the 7. This show is all about the alkanes. The alkanes, the beginning. Alkanes are the hydrocarbon compounds. Hydrocarbon compounds are a category of organic compounds which contains only hydrogen and carbon. So, the compound called alkanes are hydrocarbons. They are also called as paraffins. Paraffins are the compounds and named according to that they are resistant to attack. They are open chain compound, they are closed chain compound. It means they are cyclic compound and they may be acyclic compounds. Alkanes are also called as saturated hydrocarbons, means they don't have any double bond in their structure. So alkanes are saturated hydrocarbons. There are several characteristics of the alkanes. Alkanes are sp3 hybridized compounds. They have bond angle between carbon-hydrogen and between carbon-carbon, that is a common bond angle we call 109.5 degree. They have structure called tetrahedral structure all the time. They are majorly obtained from the petroleum and natural gas. In the alkanes, carbons are categorized as primary, secondary, tertiary and quaternary. The primary carbons are the carbons which is connected to only one carbon. The secondary carbon is the carbon which is connected to two carbons. The tertiary carbon is the carbon which is connected to three carbons directly. And the same way the quaternary carbon is the carbon which is connected to four carbon all the way to fulfill the valency of the carbon. The hydrocarbons like alkanes have special characteristics. They have sp3 hybridization. They have 109.5 degree bond angle between carbon-carbon and carbon-hydrogen. All the carbon-carbon and all the hydrogen-hydrogen bonds are strong sigma bonds. They have a specific character that they arrange in regular tetrahedron. It means they have three-dimensional structure. So this is all about the characteristics of the alkanes and a specific characteristics of the hydrocarbon containing alkanes. The main sources of alkanes are petroleum and natural gas. Apart from that, alkanes can be made in the laboratory. So let us start today's session all about alkanes, the beginning. Crack the 7. Now presenting very first question of the show, and the question is: the specific category of alkane is A. Carbohydrates, B. Hydrocarbons, C. Organic compounds, and D. Proteins. Dear friends, when we talk about carbohydrates are the compounds which contains carbon, hydrogen and oxygen atoms. So we know that in alkane only carbon and hydrogens are present. So carbohydrates is not considered here. When we talk about second option, that is hydrocarbons. Hydrocarbons are the category of compounds which contain only hydrogen and carbon. So it is the most suitable category and specific category for the alkanes. When we locate organic compounds are definitely hydrocarbons and organic compounds are definitely containing other elements too. But it is not a specific category, it is a general category, and we can put every organic compound here. Not only alkane, we can put every organic compound here, and therefore organic compounds is a general category. And when we talk about proteins are the compounds which contains nitrogen element and oxygen element both. Therefore they are not considered as alkanes and they are not considered as a specific category. Therefore the specific category of the alkane is only one, and that is hydrocarbons. So the correct answer for this question is option B, hydrocarbons. Now presenting second question, level 0, and the question is: the 5-carbon open chain unit in alkane is referred as option A, pentane, option B, octane, option C, nonane, and option D, hexane. Dear friends, the whole series which we call alk series, when we call it is 1 carbon meth, 2 carbon eth, 3 carbon pro, 4 carbon but, 5 carbon pent, 6 carbon hex, 7 carbon hept, 8 carbon oct, 9 carbon non and 10 carbon dec. And apart from that, if we go further, we can also name all the compounds. But here we ask 5 carbon open chain. So 5 carbon is a pent, and therefore we can say it's alkane, so pent N. So it is open chain. Suppose if it is a closed chain, then we have to speak about cyclopentane. But it is asked open chain, and therefore the correct answer is pentane. Option A is the correct answer. Now presenting third question of the show, question 3, level 1, and the question is: the characteristics of alkanes are A. sp2 hybridization, sigma bond, planarity. Option B. sp3 hybridization, sigma bond, 3D structure. Option C. sp3 hybridization, pi bond, 3D structure. D. sp2 hybridization, pi bond and planarity. Dear friends, we need to identify the correct combination of the characteristics of the alkane. We know that alkanes are sp3 hybridized. Alkanes are 3D structures, they are tetrahedral structures, and alkanes contain all sigma bond. So the correct answer for this question is option B, that is sp3 hybridization, sigma bond and 3D structure. So correct answer is option B. Presenting fourth question, level 1, and the question is: the percentage S character in alkanes is 25. The relation between the percentage S character and saturation is option A, directly proportional, option B, no relation, option C, inversely proportional, and option D, depends on structures, the relation changes. Dear friends, first of all, let us understand what is the matter. There are three kinds of hybridizations we consider for the organic compounds: sp3 hybridization, sp2 hybridization and sp hybridization. In sp3 hybridization, one s orbital and 3 p orbitals are involved, and therefore the percentage of s with relation to p is considered 25. In sp2 hybridization, the 1s orbital and 2 p orbitals are involved, and therefore the percentage is calculated as 33.33%. In sp hybridization, only one s and one p orbitals are involved, and the percentage of s orbital will be 50%. We know that sp3 refers to the saturated compounds containing all sigma bond. sp2 refers to the at least one double bond present in the molecule, and therefore unsaturation introduced. In sp hybridization, at least two double bonds should be present in the molecule, and therefore unsaturation still increases. So if we see that as percentage S character increases from 25 to the 50%, unsaturation increases, and therefore the relation of saturation and the hybridization S character we can find indirectly proportional. We can say that as percentage S character increases, saturation decreases. Here we ask about saturation, so saturation decreases, and therefore the correct answer for this question is that inversely proportional. So the correct answer is option C, inversely proportional. Now presenting question number 5, level 2, and the question is: how many primary, secondary, tertiary carbons are present in 3-methyl pentane? Option A, 3 primary, 1 secondary, 2 tertiary. Option B, 2 primary, 1 secondary, 3 tertiary. Option C, 2 primary, 2 secondary, 2 tertiary. And option D, 3 primary, 2 secondary and 1 tertiary. Dear friends, let us see the structure of 3-methyl pentane. You can see the structure of 3-methyl pentane is given, and all the carbons are given numbers. So first of all, let us understand what is primary, secondary and tertiary carbons. The primary carbon is the carbon which is connected to only one carbon directly, Secondary carbons are the carbon which is connected to two carbons directly, and tertiary carbon is the carbon which is connected to three carbons indirectly structures. Now we can see that in the structures, the carbon number 1, 6 and 5 are terminal carbons, and they are connected to only one carbons. So all the terminal carbon, in a shortcut we can say all the terminal carbons are primary carbons. So we can see that three carbons 1, 5 and 6 are primary carbons. We can also see that carbon number 2 and carbon number 4 are intermediate carbons. In between the chain they are present and they are connected to two carbons. Therefore carbon number 2 and 4, they are secondary carbons. It means two carbons are secondary carbons. And we can also see that carbon number labeled as 3, it is connected to 3 carbons and it is a tertiary. So the correct answer for this question is 3 primary carbons, 2 secondary carbon and 1 tertiary carbon. And the correct answer is option D, 3 primary, 2 secondary and 1 tertiary. So correct answer is option D. Now presenting sixth question, level 2, and the question is: the boiling points of isomeric alkanes are decreases with option A, increase in branching, and this is due to increase in van der Waals forces of attraction. Option B, decrease in branching, and this is due to increase in van der Waals forces of attraction. Option C, increase in branching, and this is due to decrease in van der Waals forces of attraction. Option D, decrease in branching, and this is due to increase in van der Waals forces of attraction. Dear friends, first of all let us understand the matter. Here two words we need to understand. First word is isomeric alkanes. Isomeric alkanes are the alkanes which contain the same number of carbons and hydrogens, but their molecular structures are different. It means they have more number of branches and less number of branches in their chemical structure. Now, what is about van der Waals forces? Van der Waals forces are the forces of, we can say that they connect the molecule to each other, and they exert only when the molecules are close to each other. If the molecules goes apart from each other, the van der Waals forces decreases. And van der Waals forces are responsible for increase in boiling point. So if more the van der Waals forces, more the boiling point. And therefore, we can say that when isomeric alkanes, when branching introduced, when more the branches are present means branching increases, van der Waals forces decreases, because branching will not allow molecules to come close to each other. When molecules cannot come close to each other, their van der Waals forces part will decrease, and if the van der Waals force part will decrease, then boiling point definitely decreases. Therefore, we have to identify two words pair, that is increase in branching, decrease in van der Waals force will get decrease in the boiling point. So the correct pair is option C, that the boiling point of isomeric alkanes are decreases with increase in branching, and this is due to decrease in van der Waals forces of attraction, option C. Now presenting seventh question, level 3, and the question is: how many sigma bonds, tertiary hydrogen atoms and secondary carbons are present in 2-methyl butane? Option A, 18 sigma bonds, 2 tertiary hydrogens, 1 secondary carbon. Option B, 16 sigma bonds, 1 tertiary hydrogens and 1 secondary carbon. Option C, 18 sigma bonds, 1 tertiary hydrogen, 1 secondary carbon. And option D, 16 sigma bond, 1 tertiary hydrogen, 2 secondary carbons. So dear friends, first of all let us identify the structure, and the structure is, you can see on the screen that 2-methyl butane is given. Now all the carbons are labeled. We have to find total number of sigma bonds in the structure. So if we put the required number of hydrogens in the structure, we can find total 16 sigma bonds. So all the corners, all the ends all the crossings are called as carbon, and to fulfill the valency, tetravalency of carbon, we need to put required number of hydrogens. So when we put the required number of hydrogens, we will get the total 16 sigma bonds, total 16 bonds in the structure. So we will end up with the sigma bond count, that is 16. Now second is that we need to find out tertiary hydrogen. Tertiary hydrogen is the hydrogen which is present along with the tertiary carbon. We can see in the structure that only second number carbon is tertiary carbon, and it has only one tertiary hydrogen. So tertiary carbon is having only one hydrogen, which is called as tertiary hydrogen. As we have only one tertiary carbon, only one tertiary hydrogen is present. So tertiary hydrogen is only one. We also need to find out the secondary carbons. Secondary carbons are the carbon which is connected to two carbons directly, and such kind of carbon is labeled as 3-number carbon in the structure. So 3-number carbon is the only one carbon which is called as secondary carbon, and therefore the only one secondary carbon is present in the structure. In a sum, we can say that total 16 sigma bonds, one tertiary hydrogen and one secondary carbon is present in the structure. So the correct answer for this question is option B, that is 16 sigma bonds, one tertiary hydrogen and one secondary carbon. Now friends, it's a turn to add 2 brain points. Number 1 is that to understand the characteristics of the alkane, that is sp3 hybridization, bond angle is 109.5 degree and structure is tetrahedral. Second add 2 brain point is that to understand the primary, secondary, tertiary and quaternary carbons, and as well as to understand that primary, secondary and tertiary hydrogens. And third add 2 brain point is that to understand the basic structure and basic nomenclature of alkene. So dear friends, it is all about today's show. I hope you enjoyed the show. Crack the 7.